Welcome to another edition of Chicago Crossing Model Railroad at the Bench. It's me, Eric, here with you up in the studio. We'll also be down in the train room today. And last week I talked a little bit about these. These are breakout boards for an ATX power supply, also more simply known as a computer power supply. Well, this is one half of the story, but the much more interesting half is the power supply itself. And that's what we'll talk about today on Chicago Crossing. We'll take a look at the good, the bad, and the ugly, and we'll answer the question, is this actually something that's worth having on your layout? So how do you power your layout? Chances are pretty good that you have one or more of these. And this is simply an AC to DC wall adapter. This one has a brick where the transformer is. Many of the others are called wall warts, and they have the transformer right where the plug is itself. Now, if you're like me, chances are you've seen these proliferate on your wall outlet or on your surge protector, ideally, over time. And if so, you might be wondering, is there really any way to try to condense down the number of wall warts or bricks that I have lying around for every different voltage for every different accessory on the layout? So an ATX power supply is basically the power supply for a PC computer or a Mac tower or something like that back in the old days. And what these power supplies do is they furnish high wattage, high amperage power to run everything from the motherboard of a computer to the graphics cards to the sound and pretty much everything else. And all of those devices have different voltages. What this does is it basically packages multiple voltage rails into a single box. Out of something like this, you can get 3.3 volts, 5 volts, or 12 volts. And if you're like me and you've looked at all of the collections of wall warts against the wall, chances are a lot of those actually match with the power specifications that something like this provides. So with that in mind, is there something that you could really use this for on your layout? Well, first and foremost, I would not recommend ever using this for DCC power. It's important to continue to use the power supply that's provided by the manufacturer of your DCC unit, whether it's a base station or a booster. And that's because DCC has particular voltage requirements as well as particular denoising requirements in order to ensure that the voltage on the tracks and the current on the tracks is up to spec. Something like this does not provide that. By way of example, Chicago Crossing uses an NCE power cab for its DCC system. What that means is the power cab expects a voltage of 13.8 volts, and that is sufficient to make sure that everything operates correctly at the current and voltage specifications needed for the decoders and the motors on locomotives. If I was to use something like this, I would actually see a drop in the available voltage on the track, something down to maybe 10 or 10.5 volts. And at that point, it will cause problems with the operation of locomotives, it will cause problems with the stability of sound decoders, and perhaps more importantly, low voltage on a DCC system will trigger a compensatory increase in current that could actually activate the overcurrent protection on my cab control, meaning that then I've got no trains running at all. There are certain rare scenarios where something like this could be applicable. For instance, if you're using DCC-X and you've essentially built your own DCC system. But even then, it may well be that the voltages required for effective DCC operation are greater than something like this can provide. Well, if you can't use it for DCC, the good news is you can use it for basically almost every other model railroad accessory that you can think of. Any of these rails can power things ranging from LEDs to Arduinos to crossing gate detectors, all the way up to servos and turnout motors. So the opportunities to use a power supply where everything is self-contained are reasonably limitless. The other good news is the current that this provides is also, at least within certain boundaries, and we'll talk about that later, relatively limitless, meaning that you can future-proof and expand without having to change out power supplies. So with that in mind, there are a couple of key caveats that one needs to understand before jumping into the ATX power supply game. Let's talk about a few of those. So item number 1, these things are powerhouses, literally. If I take a look at this one and I examine exactly how much power this thing can put out, what I find is that it has a maximum DC output on the 3.3 volt rail of 28 amps, the 5 volt rail 36, and the 12 volt rail 16 amps. That is one hell of a lot of power, and that's not something that you want running through your railroad. Now, it's important to keep in mind that for the average model railroad, anything that you're running is going to use probably a fraction of that. Here's a good example. The average tortoise motor is going to run somewhere around between maybe 15 to 20 milliamps, and it's going to draw that current continuously. But what that means is if you have 20 of those, you're still operating at a fraction of an amp. The other thing to consider is LEDs. An LED operates as a current-driven device that will take anywhere between maybe 20 to 40 milliamps. Likewise, these are not exactly current hogs, and they're a fraction of what an ATX power supply can put out. So that's good news. Probably the most power-hungry thing you're going to see might be like an IR detector for a crossing, or a servo where maybe you can have up to 100 milliamps draw when that servo is active. But nonetheless, this is all small potatoes to one of these. So with that, it's important to keep in mind that a breakout board like this is not meant to carry much more than what it's fused for. If you look at how this is traced out, and if you look at how this is built, this is devised more or less to run maybe at most 8 to 12 amps through the entire board at any one given time. Overloading this will simply trigger the 5 amp fuses in here, and for good reason. The board has these fuses not to protect your layout, but to probably prevent this thing from melting and causing a fire. Anything to do with power supplies is to be understood as a selfish role. It's not to protect what's downstream on your layout, it's to protect this, or as a big picture element, to protect your house from burning down because of the fact that something like this was overloaded with current, melted, and created a fire. As with everything, safety is paramount. And the one thing you should always remember when it comes to breakout boards like this, or power supplies like this, is that if you're not in the room, this should be off. There's never a reason to leave your model railroad on when you're not in the room with it. Full stop. It's important to remember that not all of these power supplies are created equal. They often have their own unique features, even from model to model and even from copy to copy. It's important to test them ahead of time, and it's also important to understand exactly how they function, at least from a high level. A power supply like this is what is known as group regulated. And what that means is that the voltage coming off the rails is regulated by a single sensor that in turn can create instability among different power rails based on how they're used. We'll actually take a look at that shortly down on the layout room so you can see exactly how something like this operates. How do you tell that this is a group regulated power supply? Well, the easiest way is actually just to look on the label. If you find that the highest currents are located on the 5 volt rail, then chances are very, very good that you have a group regulated device. That type of device can sometimes have very specific characteristics that are important to understand before you use them. On the other hand, this power supply is more contemporary in design, whereas the other one, regardless of whether it's new, features an architecture that was probably common in the early 2000s. This one is much more up to date and represents what you could find in newer computers that are designed particularly for high performance. This is what's known as an ATX 3.1 power supply. This power supply, unlike the other, is independently regulated. And what that means is that every voltage rail has its own individual sensor and its own controller. So you don't have instability between power rails depending on differential usage. It puts out 5 volts of power to the 5 volt rail, 12 volts of power to the 12 volt rail regardless. Well, here we are down in the train room. As you can see, this is the power setup for Chicago Crossing Model Railroad. You're basically looking into the back of the power rack. So here you can see the power supply, the ATX power supply. This is the old style ATX power supply. Up here is the breakout board. And up there are two wall adapters. One of those is a 24 volt 2.5 amp that runs the legacy just plug system that lights up the buildings on the layout. The other is the 13.8 volt 2 amp power supply that runs the NCE power cab. That, as well as the 5 and 12 volt rails, all run into this bank of Wagos that connects to the Cannon plug and the bulkhead connector on the other side. So all of the power for Chicago Crossing basically runs up through a single cable over to the layout. It's essentially a multi-conductor cable on the other side. So I wanted to talk a little bit about protection for all the circuitry on Chicago Crossing Model Railroad. Everything runs through a surge protector initially. That just makes absolute sense. You're probably the same way. You want something between the wall outlet and everything else. But you know, if you think about the Swiss cheese model of things going wrong, this is used in aviation a lot, but it can be used anywhere. Swiss cheese has a lot of holes. The more slices of Swiss cheese that you have, the less likely that the holes will align and allow a lethal amount of current to run into your model railroad. So what I have downstream on the positive leads of the 5 and the 12 volt rails is a 3 amp fast blow blade fuse. These are essentially just automotive fuses. That ensures that there's a couple of different layers of protection for the model railroad before the power actually gets off of the rack and into the multi-conductor cable that connects it to the layout. Now, at the site of the layout, there's additional protection in that each of these power rails has its own switch. And so what that means is, in addition to all this sort of stuff, I've also got switches that physically break the circuit for all of this power supply stuff at the site of the layout, and that includes for the DCC system. So you might think that sounds like a hefty bit of over-engineering, and yeah, maybe it is, but I will tell you I feel a lot better just knowing that that stuff is there and knowing that there's enough redundancy in there to ensure that the holes in the Swiss cheese don't align, or at least that it takes a lot more to get them there. All right, so I wanted to talk a little bit about dummy loads. You've probably heard that term before, and you may be wondering, do I need that? Is that something that's important? It is something that is important for these old style types of power supplies. And that's simply because they all have a controller inside that basically sets a duty cycle related to sensing a draw of current from the device. So in this case, if I turn this on, then the fan actually begins to spin. If I turn the board off, the fan stops spinning. And so it's important also to note that right now the 5 and 12 volt rails are actually switched off at the level of the layout. So there's no load coming from the layout that is driving the unit to be on. I think in this case, this LED and the little resistor behind it actually are a sufficient dummy load in order to ensure that this unit actually turns on. Now, if you need to make your own dummy load, the easiest thing to do is to use something like an aluminum coated resistor. In my case, I have a 22 ohm 50 watt rated resistor, which is well above spec for serving as a dummy load in this particular case. I did that so that it stays reasonably cool. And so what you would do if you were making your own manifold or breakout board for higher amperage usage is you could actually just take one of the 5 volt rail wires and one of the ground wires and then run that dummy load across those wires. And then you can just mount the resistor either within the airflow inside of the case or on a metal surface in order to help keep it cool. And at that point, your power supply will turn on just fine. So what I wanted to do is basically show you what the voltages are on the power supply with only that dummy load active. And essentially what you can see here is it's about 5.33 volts. That's actually out of spec for an ATX power supply. They're supposed to be maybe 250 millivolts above or below the spec for the rail. So in this case, it's actually just out of spec to begin with and a little bit high. And that might be just owing to the fact that it's a relatively cheap device. This one is sitting right at spec, 12.25 volts. Let's go ahead and switch on the 12 volt rail and see what happens to the 5 volt rail. And so now if we measure what happens at 5 volts, 5.35. So essentially all we did by turning on about 40 or some odd LEDs is to modulate the voltage up by about 20 millivolts. I mean, that's a tiny, tiny, tiny fraction. That's not something like going up to 6.5 volts and actually triggering the over voltage protection on the unit and causing it to shut down. So if you're running a relatively small layout off of this without, massive amounts of current, you're not really shifting that power by all that much. If we look at the 12 volt rail, you can see the voltage drop that occurs because of the fact that that rail is now drawing power. So we're at about 12.09 volts there. Now let's turn on the 5 volt rail and see what happens. Okay, now we've got some nice animated electroluminescent signage. And so what that signage does to the 5 volt rail is basically to bring it down by, about 40 millivolts from the 5 volt unloaded state. And if we look now at the 12 volt rail, it's about 12.2. And so that just goes to show you that you don't see all that much wobble in one of these power supplies, regardless of which voltage rail is actually on. If you're loading this thing up by tens of amps on the 12 volt rail with nothing on the 5, chances are you're going to see a larger wobble. And you could actually trigger the over voltage protection on the 5 volt rail. All right, so just the last little segment down here, I wanted to show you what happens when you use a higher spec ATX 3.1 power supply for providing power to a board like this. So we'll go ahead and turn this on. And let's just measure unloaded the voltages across these rails. So for the 5 volt, we are getting like 5.01. We're within 10 millivolts of the specified voltage for this. This is 12.08 sitting on the 12 volt rail. So again, we are well within specification here. So let's go ahead and just turn on the LEDs. And now let's measure what is happening on the 5 volt rail. So we're at 5.02, pretty much within the error of a meter like this, I bet. So you have a tiny, tiny, tiny drift with something like this. Is it necessary to buy something like this for your model railroad? So it offers certain advantages in terms of the stability of the power to the rails. It has much less of a voltage drop across the rails or shifts in one direction or another. If you have extremely sensitive electronics, then you don't have to worry about that type of wobble, particularly if you're running larger amounts of current out of an ATX power supply. But hopefully this was informative in terms of how these power supplies actually behave in a real world setting connected to a door size model railroad. All right, we'll head back up to the studio and give some final impressions. And so with all of that in mind, you're probably wanting to hear the answer to the question that you've been asking maybe since the start of this video, which is, should I switch over to an ATX power supply for my model railroad? Should I trade in a few of these for one of these? And the answer is, well, it depends. So what I mean by that is it depends on a couple of things. Number one, what's the power architecture of your layout? If all of your accessories run off of a single 12 volt bus, either because they're all 12 volt compatible or because you use something like voltage converters to step down those voltages to other things that are useful, then spending the time, money, or energy to swap out power supplies may not be useful. You can find a world of high quality wall supplies that will provide high quality 12 volt power for your model railroad at a cost that is equivalent or certainly less than a high quality ATX 3.1 power supply. It really may not make a lot of sense for you to invest in something else when you've got something that's actually working quite well for you and has headroom for expansion. On the other hand, if you're like me and you've got multiple voltage buses for different sets of accessories that you use on your model railroad, and you want to condense down the number of wall adapters that you have behind your surge protector, well, it could be that something like this is worthwhile. It could also be, depending on the sensitivity of your equipment, that maybe you actually do want something like this. This is an equation that all revolves around time, money, effort, and interest. And so for that reason, there's not necessarily a right answer to that question. It's mostly, is this something that actually makes sense to you as a hobbyist and to you as an end user of items like this? Do you want to pay for this? Do you want to pull this out of your computer? Or do you want to keep using the wall warts that you have? It's an equation that only you can answer for yourself. But with these insights, hopefully that provides a little bit of additional information to help you make a decision. Lastly, and just to put this into context, yes, Chicago Crossing does have, 3 different voltage buses on it, but never in the point of its existence did it ever need 3 voltage buses. And this is an honest confession from somebody who spent the better part of 6 months rewiring the thing so that it basically matched that spec. But I'll simply say this, the biggest reason that I did that was not practicality, it was joy. This is, after all, a hobby. And part of what I find to be fun about a hobby is to take concepts and engineer them, or even over-engineer them for something that is a door-sized layout, because I actually find a lot of enjoyment in that process. And most importantly, I learn a lot along the way. If I had simply stuck with the same set of wall warts and the same set of bad wiring that I had before, I never would have learned certain principles about electronics that I know now. And it's hardly to cast myself as an expert in electronics. I'm absolutely not. But it did provide some insights that I never had before. And if anything, for being a hobbyist, it's also being a lifelong learner. For me, that's basically a matter of I wanted to switch this over to an ATX rather than that I needed to. So that's something to keep in mind. You can over or under engineer your model railroad to your pleasure. This can be part of that process, or it could not. Either way, you still get to have fun with your model railroad, and that's actually the important thing. All right, let's leave it at that for now. I hope you have a great rest of the weekend and talk soon.